I'm Anil Kumar, and with the help of this video, I'll teach you a few basic concepts about modeling trigonometric functions. The question here is, write one equation using the cosine function and one using the sine function that would result in the same graph as y equals to 5 cos of 2 times x minus 45, and these are in degrees. So what I will do here is, first we will graph, then we'll write down the equation. Let's understand the graph itself. So let me draw one cycle to explain the whole concept. So when we have the equation, which is y equals to 5 cos of 2 x minus 45 degrees, then it really means that x is same, which is x-axis, correct? That is the y-axis. However, the amplitude is 5 times. So if this is 0, so we have plus 5 will be our maximum, and minus 5 is going to be the minimum. So I'm just drawing some dotted lines here so that they will help me to sketch the function, right? And then we have t, I should say the value of k. That really indicates, let me write here, k is equals to 2. It really means that within 360 degrees we have two waves. That means the time period is 360 degrees divided by 2, or 180 degrees. So we have time period of 180 degrees for a cosine function. So what I do normally is, I will draw two curves, one without horizontal translation, the other one with horizontal translation. Now the cosine curve starts with the maximum, so we'll start from the maximum here and just draw our function, which is kind of like this in general, right? So that is what my cosine function is, and of course it goes on and on, right? But we are concentrating on one wave at present. Now what we know here is, now imagine that I have this function, which basically for me is y equals to 5 cos of 2x, right? Since I have not incorporated minus 45 degrees yet. So if I have that, then this is 0. Time period for us is 180 degrees, right? Half of that is 90 degrees, and this becomes 45. See how easy it is. I'm just showing you that it's not a very difficult job. And you know these maximum and minimum values, correct? Now what really happens is that we have to sketch the function, which indeed is with a horizontal phase shift of 45 degrees. Now how to do that? So for that we will shift every point by 45 degrees. That means quarter of the cycle, right? So quarter of the cycle. So this point moves to 45 degrees, and that goes to 45 degrees. Here it goes to 45. This position reaches there, and that point reaches there. So we get another wave, which is our final wave, right? So you can actually graph this wave, and that is kind of the cosine function, right? So this is your cosine function, which has now minimum at 135 and the maximum at 45. Do you get the point? So that function which I have drawn is indeed y equals to 5 cos of 2 times x minus 45 degrees, correct? So that is how in 2 steps you can sketch your function. That is one thing which I wanted to share with you. Now the real question here is, write one equation using cosine function and one using sine function that would result in the same graph. So we want the same graph. We have been given equation as y equals to 5 cos of 2 times x minus 45 degrees, right? Now what we see here is time period t is 180 degrees. What is quarter of the time period? Quarter is 180 degrees divided by 4, and that is 45 degrees, right? Now why did I do quarter? Every time when you have sinusoidal function, actually the key points are spaced quarter of the period away, correct? So if total time period is t, then t by 2 we have the middle point, and by quarters we have the other two, right? That helps to get us the equation. Now this is our final wave, which let me use the right color. Here it is. Okay, which if I extend, it will be kind of like this, right? Quarter of the cycle, correct? So like this. Now we can easily write down different kinds of equations for this wave. If I have to write a cosine function, I could write with the minimum going upwards. In that case, my equation will be, since we are starting with minimum, minus cos. Do you understand? 2 times, everything else remains same, phase shift changes. X, now the minimum occurs at 135, right? So half the cycle away. Minimum will be half the cycle away. So it is at 135, right? So that is the quarter, and half is 90. If you add 90 to 45, you get 135. So that is how you can get, with a negative sign, the cosine equivalent of the given equation. For the sine, we can think about the starting point, which is here, or we could think about this point, or even that point, correct? So these can give us sine waves. Let me write down few equations for you. If you consider this particular point, in that case, we know that the wave really starts like a cosine function, which starts from the axis, right? So it is at 180 going up. So it could be minus 5 sine 2x minus 180, right? So it moves 180 degrees away. But you could think about this point also, right? It could start from 0. In that case, the equation would be plus 5. Do you understand? Since it moves upwards from here. I'm sorry, this was positive. Sine is moving upwards from here. If I would have taken this point, then it becomes negative. I'll write down that equation also. Let me write down the first one, which is 5 sine 2x. No phase shift at all, right? Since it starts from the origin. As I was saying, I could actually give you equation from here also. That could be minus 5 sine 2x. That starts negative, but from 90 degrees, correct? So x minus 90 degrees. So likewise, we can write so many different equations for the same function, right? So go through this video, try to understand the concept, right? Cosine and sine are related with quarter of the cycle. That helps to work out the equivalent equations very easily. I hope it helps. Thank you and all the best.